Good morning, Year 8. So we're going to continue looking at graphs, but we're looking at real-life graphs this time. So what we've got here is a picture of a graph that shows us the depth of water in a bath and time. So as time continues, what happens to the depth of water? Okay, so think about what's happening between R and S. So we can see the depth of water is going up. Okay, what might be happening? Okay, so I would suggest maybe that both taps are running and therefore the bath is filling quite quickly. Okay, so from R to S, I'm going to say 2 taps are on and the bath is filling quickly. Can you suggest what might have happened between S and T, T and U, U and V, V and W, W and X, X and Y, Y and Z. So all I want is a sentence for each section. So I've given you a sentence for R to S that 2 taps are on and the bath is filling quickly. Can you give me a sentence for S to T? Can you give me a sentence for T to U, U to V and so on? Okay, so pause, have a think about that and see how you get on. Okay, so once you've done your sentences, press play. Okay, so this is my suggestion. Don't worry if you've not got exactly the same thing. Okay, but okay, so I've just put the graph in here so we can see it. So we said R to S, the water was rising quite quickly. So both taps are on and filling the bath. Okay, or bath is being filled quickly. Okay, so S to T, the bath is still being filled, so that the water height is still going up, but it's not as fast. So it might be that one tap has been turned off, or might be that both taps have been turned down. Okay, but it's still going up. All right. So then we look at T to U, and the height isn't changing. So at this point, the taps have been turned off because the water level is remaining the same. U to V, if we look, the height jumps up suddenly. So that can't be taps going on. That's got to be something getting in the bath which makes the water go up. So this is when the child gets in the bath. So the water level rises instantaneously. It's going straight up. V to W, the height isn't changing, so that's the child is staying in the bath. Okay, the water level remains the same. W to X, now the water's level is going down, and because it's going down gradually, that's not because the child has got out, so it's got to be something like either splashing and lots of water being tipped out, or more likely that the plug is taken out and the water level is going down. Then from X to Y, the depth goes down very suddenly, so that this is the child getting out, and Y to Z is that it just continues to empty. Okay, so the plug's still out and it empties down to here where there is no water. So hopefully, even if you didn't get those right, or you got slightly different answers, you've understood what's going on with this graph. Okay, and that's what this lesson's about, is drawing and interpreting this type of graph. So let's have a look here. So I'm just going to, okay, so we're on 2 screens now. Oh, I just need to flip to the right screen. There we go, that's what we need. Okay, so on the left hand side, I have got different types of graphs and they're all about baths. Okay, so again, up the side we've got level, and across there we've got time. Now it doesn't say it, but each of these little squares is worth a minute, and that will help you in a minute, because on this side we've got 6 descriptions. So what I'd like you to do is to match the graph to the description. Okay, so what I suggest is you read through the descriptions carefully, okay, and then look over and see if you can work out which graph makes sense. Okay, so again, have a pause, all right, have a go at those, and we'll come back and look at the solutions in a minute. Okay, so I'm just going to get myself a line. And we will join up the graph to the description. So if I look at the first description, it says Paula was in the bath for 2 minutes before turning the tap back on. Then she got out to get the shampoo from the cupboard. So we know it was filled, we know she got in, and then we know it was filled a bit more. So if we have a look, on this one, there's no sign of anybody getting in because the water level would rise straight away. So that one's not there. This one, the bath was filled, somebody got in, stayed in for 2 minutes, got out, and the bath was emptied. Okay, so it might be that one, but this one says that Paula was in the bath for 2 minutes before turning the tap back on. So she was in the bath 2 minutes, but she didn't put the tap back on that one. So we look at this one, so she's filled up, she gets in for 2 minutes. Okay, so she's filling up again, so we've got the tap back on again. Then it looks like she got out to get the shampoo from the cupboard. Okay, and then it looks like she got back in, stayed in the bath, got out, and let the water out. So that looks like the best match for here. Okay, there's no other ones where it shows that she got out and got back in, so I think we will match that one to that one. Oh, it's not going to go across my screen. Okay, so we will do this as, okay, so I've numbered the graph, so this one we're going to say is graph 3. Okay, so Joan's bath tap was running slowly, so her bath did not get very full before she got into it. Due to this, she only stayed in for 3 minutes before getting out and then taking the plug out. So we're looking for a bath that didn't get very deep. Okay, so this one looks like it got quite deep. This one wasn't too deep, got in, but we've only got 2 minutes here, and it said she stayed in for 3 minutes, so not that one yet. This one just gets filled and then emptied. Okay, this one doesn't fill very far, get in, 3 minutes, get out, emptied. So I think this one, 5, matches that description there. Harry stopped the tap after 2 minutes because he had to run to the shop. When he got back, he ran the tap for 3 minutes before getting in. Okay, so this one, the tap's just running all the time. This one, the tap was running and then somebody got in, so it wasn't stopped. This one, the tap was stopped, but nobody got in. This one, the tap was stopped and somebody got straight in. So let's have a look at this one. So ran for 2 minutes, stopped, so the water level stays the same. Then ran for 1, 2, 3 minutes, then got in. So I think that must be graph 6. Okay, Monica does not like baths, so only stayed in for 2 minutes. So we're looking for a flat top of 2 minutes. Well, that's this one here, just 2 minutes staying in. Okay, so that's graph 2. So what have we got left? We've got graph 1 and 4, okay, to compare. Amelia forgot about her bath and it was overflowing for 8 minutes before she managed to take the plug out. So she didn't even get in, it was overflowing. So if we look at this one, it fills up, okay, stays at a level for 8 minutes and then is emptied. So, okay, so when it's overflowing, the depth of the water is going to stay the same because water's coming out as fast as it's going in. So that is that one. This is the overflowing bath. Nobody got into that one. So that's number 1. And then it says Nia started to run a bath but then changed her mind and took out the plug. So this one ran a bath to this point and then just emptied it. So that's number 4. So hopefully you've got an idea of what's going on there and you've got those correct. Brilliant. Okay. I'm just going to change what we can see. So go to single page display. There we go. So I want to look at this here. So we're going to look at different shaped vessels. So far we've just looked at a bath, which is a sort of rectangular shape. Okay. I want us to consider different shapes now, but we're going to start with looking at different widths. Okay. Okay, so I've got this vase that is very, very narrow, this vase which is very, very wide, and this vase which is in between, but they're all the same height, okay? And then I've drawn graphs, okay, again measuring the height of the water against time, okay, and they all finish at the same height because they are all the same height, okay? So imagining we're filling the vases right to the top, okay? So what I want us to think about is which graph do we think matches which vase? So when we pour water in A, okay, does the water height go up very, very quickly, or is it quite slow? When I fill graph B, does the water height go up very quickly, or is it much slower? And what about C? Okay, so hopefully you've realised that this one's going to be going up very quickly. If you're not sure, see if you can find in your house a very, very narrow glass and maybe a very wide bowl, and just look at the height pouring in at the same rate. Okay, this one is going to fill very, very quickly and be full much sooner than this one. Okay, this one will take a lot longer to fill and will fill much slowly because it's got a bigger area at the bottom to fill. Okay, and this one will be in between. So we've just done lots and lots of works on gradients, okay, and we said steeper graphs have higher gradients, but also steeper graphs represent things that are happening quickly, okay, when we're measuring against time. So this A is actually represented by the red graph here, okay. All right, this is saying that the height increased quickly, and graph B is represented by this very shallow graph here. It took the height increased a lot more slowly, and it took a lot longer to get to the same height here. And then obviously C is in between, okay? So what you need to make note of is when we're plotting the height of water against time, the graph for the narrow vessels will have a steep gradient. That's that key word that we've learnt before, okay, a steep gradient, and the graph for wide vessels will have a shallower gradient. And that's going to be important because from now on we're not going to be looking at just narrow and just wide. We're going to look at vessels that change shape. So we might start with a steep graph and finish with a shallower graph, okay? So if you can get that into your notes. Okay, so we are going to look at a website called MyMaths. You might have seen it before, but if you you can go to www.mymaths.co.uk. I'm going to do it on here, so it's only if you want to have a look at it yourself. But if you do, I'll put the username and password on Show My Homework. Once you've logged in, you'll get to this page and you need to come to the algebra section. And then in the algebra section, there's a graphs section. Okay, and we're looking for real live graphs. So if we scroll down, we've got it there. Okay, and we're going to look at the lesson. Okay, so if you want to look at the first 3 pages, then that would be good, but I'm going to focus on the last 4, so I'm going to look at this one here. So we've got a bath, okay, it's similar to the shape that we've just looked at with the vases, a very cross-section of a rectangle, okay. So you're asked which of these graphs match that bath. So if you want to have a go at this on your own, get yourself logged in and have a go. If not, just have a guess in your head and I will press an answer. Okay, so at the moment the bath is empty. So if I look at this graph here, okay, this graph is suggesting that the bath is already slightly full of water because it's not starting at 0. So I don't think it's that graph. This graph here says the depth stays the same all the way, and it's certainly not empty, it's starting here. Well, this bath is empty, and in a minute we're going to turn the tap on, so it's going to be filled. This graph starts empty and fills at a steady rate. Now that is possible. This is going to fill, or the depth, should I say, is going to increase at a steady rate. This one, we've not seen anything like this yet. It's a curved graph. So the gradient starts very shallow, but the gradient is increasing, so it's getting steeper and steeper and steeper, which suggests that it starts filling slowly, or the height increases slowly, but then increases more quickly and more quickly and more quickly again. Okay, well, for this graph, this bath, I think it's going to be a steady increase, so I'm going to opt for this one. So watch what happens when we fill the bath. Let's mark it. So there we go. So the depth increased steadily. Okay, so we get this graph, so we were correct. So let's have a look at number 5. So slightly different bath here. Okay, it's not a rectangular shape. We've got this bit here, so we've got to think really carefully. How is this bath going to fill? All right, so we've got a very, very small surface area here, and as the bath fills up, the surface area at the bottom is getting bigger and bigger and bigger. So how is that going to affect the depth? And then we get to this point, okay, and the surface area stays the same. So how is that going to affect it? Okay. So let's have a look at the graphs. So this is the sort of graph we had last time, which says it's going to fill steadily from 0. Well, it's not the same shape graph, and we've already said that actually we've got a very small surface area, so this is going to fill. This is going to get filled quite quickly compared to the last graph, and it's going to slow down as we go up. Okay, so it's not going to be this one. Okay, if we look at this one, this says it fills quite quickly to start with, okay, and then it slows down to a level, and then it empties again. So we're only looking at the graph being filled. This going down is suggesting it's emptying, so it's definitely not that one. So then we've got these two curved graphs to consider, okay. So this one here suggests that it is filling slowly to begin with, because it's quite a shallow gradient, and at the top here we've got quite a steep gradient. So this suggests we're filling slowly, and then we get quicker and quicker and quicker, whereas this one suggests we're filling quickly, and then we slow down, and then we have a straight bit. So we've got to decide between these two. So again, let's go back. We've got to think, this bit here is going to fill, it's only a small surface area, so it's going to fill quickly initially, and it's going to, as it gets deeper and deeper, it's going to slow down. And then when we get to this bit here, we're going to be very similar to the last graph. It's going to be straight. Once we get to this point, the graph's going to be straight. So it's going to be this one here, but let's have a look at what happens when it fills. Okay, so let's have a look at number 6. Okay, so different shape again. Okay, so again we've got a small surface area at the bottom, very large surface area at the top. Have a think about which one you think is going to be correct. Okay, so we've got lots of curved graphs here. So we look at this one, it suggests it's filling quickly, then it sort of stops and maybe goes down a little bit, so maybe emptying and then carries on filling at a steady rate. Or we've got something that fills slowly to begin with and then speeds up. Or this one, we've got fills slowly to begin with, speeds up, and then fills slowly again. Or we've got something that fills quite quickly, so we've got quite a steep gradient here, so it's filling quickly and then slows down. So hopefully, with all those descriptions, you'll have gone for this one here. Okay, and we can see it filled slowly, the height increased quickly at the bottom because we had a small surface area, but the wider it got, the slower it got, so we had to curve off. Okay, hopefully you found those quite useful. So I'd like you to have a go at some of these now. So we haven't got the interactive part, but you can have a good go at matching these 4 shapes to 6 of these, these 6 shapes to 6 of these graphs. You'll obviously have 3 graphs left, so it would be good if you could have a go then at maybe drawing a funnel or a vase that would match the graph, but start first of all by thinking which graph matches which shape. Okay, this has come up on GCSE papers before, but it's just good fun to think about. So have a go at that and press pause, and I will put the answers up tomorrow or next lesson.